Welcome back to Slowpoke Café, the series where I turn Pokemon into a fully fledged cooking game. In the last episode, we got our project set up and the player and Pokemon moving around. But you know what they can't do? Pick up a berry. Or put it down. Or cook, actually. I should really start working that feature, shouldn't I? And that's the plan for today's episode, setting up the cooking mechanics. But before we start throwing spaghetti at code, let's break down what we actually need to build today. First up, we need to move. No, not the player. We need to move items, which entails building a pickup system, where the player can grab an item, carry it around, and plop it down somewhere useful. Okay, so we need a system to pick up items. But what about a system to cook? Well, in most cooking games, you can transform raw food into proper ingredients by interacting with them or using the proper station. Then, with the proper ingredients in hand, you can combine them to create a complete dish. For that to work in our game, we will need an interaction system. But the items need to know what happens when you interact with them. Does it cook? Does it chop? Does it transform into soup or disappointment? To handle that, we will need a system to track recipes and ingredient progression. If you think about it, it's like Pokemon evolutions, but with onions. Now that we have an outline of what needs to be done, let's start coding the pickup system. For the pickup system, we will need a way to store item data so we can differentiate different items from each other. To make this happen, we're using the power of
Scriptable objects.
Scriptable object is a data container that allows us to store and manage data independently of game objects. Our item scriptable object will include the following fields: name, sprite, item type so we know if it's a food or a plate, and prefab, the actual game object will spawn onto the scene. Now that we have a way to store item data, let's write the item script. Each item will have a reference to its item data scriptable object, a boolean to check if it's currently picked up, so we don't try to pick it up twice, and two functions: pick up, which parents the item to the player, and place down, which drops the item like a hot potato. Let's check out an example setup. Here we have our oranberry item. It has a model for the oranberry and the item script. The item script holds a reference to the oranberry scriptable object, which holds all the information we need for this item. So we have our items now, but nowhere to put them. Let's fix that by introducing the iPlaceable interface. Any game object that inherits from this interface will be a valid object to place items on. The interface will contain the following properties: a reference to the last item placed, a list containing all the items placed on it, a list of transforms to position items when they're placed down, and three functions. The canSetItem function checks if the item can be placed here, setItem function that changes custody of the item to itself, and removeItem function which releases the item. We now have our items and the surfaces to place them on. Now we just need the player to move the items around. For that, we'll create a pickup controller. This script's a little complicated, so I'll just describe what it does. First, the player needs to be able to select a placeable. We will do this by creating a box collider in front of the player, and registering any placeable that enters it. When the player presses the pickup button, the controller will run the following logic. If the player is not holding an item, check to see if the placeable has an item. If it does, pick it up. If the player is holding an item, then check if the selected placeable can accept the item. If so, place it down. If the player is holding an item and the placeable has a plate, put the item on the plate only if the item is a food type. If the player is holding a plate and the placeable has an item, put the item on the plate if the placeable is holding a food item. If the player is holding a plate that has an item and the placeable is holding a... Now it's time to create the interaction system. First up, we're going to create the interactable script and add it to all the counters. When the player is in range of an interactable, they can hold down the interact button, and after a set duration, the interaction is complete. However, there's still one issue. The interactable doesn't know what to do once the interaction is completed. This is where we introduce the recipe data and recipe manager script. The recipe data script will be another scriptable object, and it will have the following fields: a list of input ingredients, an output item, and an action. The recipe manager will keep track of recipes for each counter. Each time an item is placed on a counter, the recipe manager checks for recipes that include that ingredient. Any recipes that don't are discarded. Once all the required ingredients are present for a recipe, the interactable is enabled and is ready to perform an interaction. When the interaction is complete, the recipe output is created. Alright, now that we got all the scripts and systems in place, it's time to put it all together. So here we are, inside the kitchen of Slowpoke Café. And today's special, a 5-star FDA unapproved Slowpoke burger. First things first, let's raid the pantry. The player will need a bun, an onion, and of course, a freshly harvested Slowpoke tail. Don't worry, it grows back. With our ingredients in hand, we start with the tail. Chop it up into a patty, drop it into a skillet, and place a skillet onto the stove. Once the patty is cooked, we can place it on the bun. Next up, the onion. No cooking required, just a quick chop and boom. Now we slap that onion slice onto the bun and voila! One Slowpoke burger, medium rare, and ready to serve. Let's not keep our customers waiting any longer. Looks like they aren't a big fan of the burger. Let me fix that real quick. And look at that, an empty plate. Let me just take it over the sink and clean it up, before anyone asks too many questions. And just like that, we have a fully functioning kitchen. But this cafe isn't meant to be a one-human operation. No. Next episode, we're putting Pokemon to work.